I'm Tim Ventura, and we're joined today by Dr. Jack Sarfatti, a theoretical physicist well known for his research into the UAP phenomena and consciousness. Dr. Sarfatti studied under Hans Bethe and other leading physicists from the Manhattan Project in the late 1950s and early 60s at Cornell, along with studies at the UK Atomic Energy Research Establishment, the Max Planck Institute for Physics, the International Center for Theoretical Physics, and work as an assistant professor of physics at San Diego State University. Dr. Sarfatti has described the CIA and DoD asking him to work on both the physics of consciousness and the propulsion of flying saucers back in the 1970s, and has developed a comprehensive model to explain both problems using mainstream battle-tested physics of Einstein's theory of gravity and quantum mechanics. So Jack, welcome back, sir. It is a pleasure and an honor to have you with me. You have done so much. In fact, we were negotiating over how much to put in the intro, and I figured what we do is keep the intro short and then just come back to a lot of this in the body. I want to start with the headlines, sir. So what are your thoughts on the current news headlines right now about the UAP Disclosure Act 2023 being quote unquote effectively gutted?
Oh, gutted. Oh, I didn't want you to say. I haven't been following it. I've been too busy doing, the physics.
Okay, well,
I mean, tell me give me an update. What's the latest?
Oh, okay. Well, and I let me prepare the audience too. So this is a little bit less structured than our normal interviews. We have a ton of stuff to go through, and so just so the audience is aware of that. So the UAP Disclosure Act of 2023. This is the Schumer-Rounds Act, right? Chuck Schumer and Mike Rounds. So what they did was they added this act in. Apparently, they had pushback from, I believe, 2 House members, and then they also got some Republican Senate members involved with that. They pushed back. They ended up negotiating. They took out the eminent domain for UAP stuff. So there's no eminent domain.
Okay, wait. Can you explain what the eminent domain means exactly?
So if I understand this correctly, right? And again, I'm not an attorney or a legislator, but the idea was they wanted to have, to begin with, an independent review board that was going to collect all of this information and then find out how to make it public. They were talking about public disclosure and a public disclosure timeline. And so that was pulled. And eminent domain would be government ownership over UAP materials owned by defense contractors. And that has been pulled also. So those two things are gone. I believe there was one other aspect of this that was removed also. So they've taken a lot out of it, I guess. And it's leading to the term that I've seen on Twitter is what's called catastrophic disclosure. That's and I guess what the difference is that people feel like it's going to come out anyways, right? I mean, your work is one example of that.
It's already out.
Yeah.
All right. So do you want me to make a comment now or what?
Yeah. I mean, what are your thoughts on where all of this is?
Okay. I have conflicts about this. Okay. Both pro and con. Unless Jack Sarfatti is on that review board, which I guess they're not going to have, unless I'm on it, it's worthless. And I know this sounds like an arrogant, people are going to say, attack me on this. But the fact is, I'm the only real PhD level physicist, who understands what's happening. None of these guys do, including Eric Davis. Eric Davis has a PhD, but he's not. He didn't study with Hans Bethe. He's not top level. He doesn't, And again, I probably will anger a lot of people by saying that, but that is a fact. And so what I see now is that all the main people, who are the main players? Main players are like Christopher Mellon. He means well, all these guys. We have areas of agreement, but Chris Mellon, Gary Nolan, Jacques Vallée, Colonel John Alexander, Louis Elizondo. All of us are on the same page on the core narrative, which means we all agree, all of us together, UFOs are real. Okay. And I think most of us agree it's certainly a military concern. Actually, it's a military threat. We can go into details why I say it's actually a military threat. And the aliens are here now. Our disagreement is over the details of the physics, which most of them are not qualified to even second guess me on that.
Well,
I mean, Chris Mellon isn't. Eric Davis has said that he disagrees with my details of my warp drive, but he's never said exactly why. I mean, what we should do is have a public debate, with several physicists, the peer, we should have an intelligent professional level discussion of what he agrees with, what he doesn't agree with, but they avoid that, and that's not a good sign. Okay.
Now, but if I could jump in for a moment, this is kind of at a level, I don't know how you would describe this. This is at a less granular level than even the physics. And the impression that I've had, and again, I am no expert, but if what David Grush says is correct, even just substantially correct.
No, it is substantially correct, because just let me say, what David Grush says is substantially correct, because I have independent military intelligence corroboration of it on several different sources.
So from everything that I have seen, then if he's right, then none of the people that you mentioned, yourself, Eric Davis, Chris Mellon, any of those folks are in this defense contractor circle that actually has these materials. That's the impression that I have. And I don't know who would be. And I think that is the challenge with this UAP Disclosure Act.
Okay, but in a way, that's true. You may be right. I don't know. But in a way, it's irrelevant. It doesn't matter.
Yeah.
Because the physics of it, the explanation, the understanding of it is very elementary mainstream physics. And most of the people you mentioned are very hostile to my position on this, and they won't even discuss it. They pretend I'm not even there, like a non-person. It's like the Soviet Union.
Well, I think this goes to compartmentalization, though. And that's
again, more than that. It's more than that. There's a political. I don't want to get into all the details now. There are political reasons for it, national politics reasons for it. But the fact remains that internationally, the Russians invited me to Moscow in July. I didn't go, but the Russians are actually take what I say on this subject, on the physics part. They take it very seriously, and we have to assume that they are running with my ball. They're working on it. They understand it. They're very smart physicists in Moscow, so they were already working on it. So this is the fact that people like Christopher Mellon and even Gary Nolan, he got angry at me. He called me. What did he call me? A narcissist, a giant narcissist.
Again, the impression that I get is that everyone that we have seen in the media, is outside of this core group that David Grush is talking about.
But the point, I agree, but the point I'm trying to make is that this whole thing is basically a technical physics problem.
Yeah.
If you understand the physics, a lot of these issues are either irrelevant or they're explained. We know exactly, conceptually, we know how these things work. We can explain just about everything qualitatively. Now, what we don't know yet is how to go into the engineering lab and build our own craft, because that's a big job. But of course, now I happen to know that the United States has at least one craft. I have a lot of detailed information on that one, and if they would let me and my people have access to it, we'll be able to solve the problem. Probably
Well,
within a year or two.
that's the panel that we should have. In addition to a historical review panel, I think we should also have a physics review panel that's able to look at
Yeah,
whatever materials have been
yeah.
recovered and explain them.
It's only the physics that's important right now. We can't speculate on the motivations of these aliens. And by the way, there are many different kinds of aliens. A lot of people saying that, but I happen to know that is the truth. And I think I said in the last one, I know directly of 3 different kinds of non-human intelligence aliens, living, alive, not just dead. 3 different kinds. One is the standard 3-foot grays with the big eyes. And by the way, there's the science fiction or the Hollywood depictions of them are quite accurate. They're completely accurate, actually, because I've actually, I know this now for a fact.
Well,
So
now,
those little grays, they're real. The others are these like 7-foot kind of hostile, dangerous-looking reptoid, reptoid humanoids, and they may be dangerous. And the third kind are the sentient orbs that a lot of people are talking about, the plasma orbs, and these things that are being seen in the atmosphere. All that stuff is real, and it's all explained by the physics work I've been doing for the last 50, 60 years.
Yeah. See, and the challenge that I see is, and I know, like, you've been able to come by more information than more people by far. But I also know that a lot of what you've been able to obtain is bits and pieces, right? And again, this is the idea of putting together some kind of a comprehensive panel to be able to actually look at what is there and say,
Okay.
this is the model we have, this is how it fits. That would be wonderful.
Yeah, well, yes, okay, I agree. But the point is, it's not a difficult problem. That's what I'm trying to. It's actually easy. This is the kind of physics you need to understand every aspect of the phenomenon. Every aspect is something that could be taught by the senior level of a good undergraduate physics curriculum at San Diego State, even at any decent college. Well, before they went woke and all that stuff. If they think that mathematics is white privilege and all that, then forget that. But I'm talking about a legitimate science education institution. Undergraduates in physics majors and engineering majors can understand everything. It's not difficult. See, this is very important. It's not difficult. It's easy conceptually.
And this gets us into 2 really important points, I think, that I should bring up for the audience. The first one is, you have said that we don't need official disclosure to replicate this technology. And the second one is that the defense contractors reportedly don't understand how this works themselves.
Right, of course they don't.
Yeah, it's too compartmentalized. They don't have the right people. They're not able to share information internally. They're not able to get there. That makes complete sense to me.
Yeah. And I know that for a fact, because I know that a particular person, tried for several years to figure out how they worked and failed. Okay, and that's basically why I've been brought in, because now some people are smart enough to realize that I've solved the damn problem. I was asked to work on it by the CIA, by the Defense Department agents back in the 70s. Around the same time, when I was at Stanford Research Institute with Harold Putoff and Russell Targ and Edgar Mitchell, and you can hear you can hear a sound, an audio of that first initial meeting in 1973. It's on SoundCloud. Just do Jack Sarfatti CIA SoundCloud, and you'll hear the 1973 meeting.
Well, and again, I should point this out for the audience. So I'm on a lot of lists. I'm on your list as well as many others. you have been working on the physics. This is, again, one of the things that gives you a tremendous advantage is you have this model. You've been working on it for decades. You have also worked with many of the top
Yeah,
physicists
but
in the
let me
world
explain.
on
Yeah,
this.
but wait a minute. I just want to get something clear because I don't think you were clear that. Yes, I've worked with many of the top physicists, but not on this problem, on other problems, on conventional stuff. So none of these people have helped me solve this problem. The only one who's really worked directly with me, actually a couple now, Keith Wanzer, this guy Keith Wanzer, who's professor of physics. He's retired now, I think, at Fullerton, the same department, the same faculty at least as Jim Woodward, who you interviewed. And we had a brief collaboration, I guess, starting around late 2019 to about 2022. And so Keith made a contribution to what I'm doing that may turn out to be important. The problem which it was Julian, I guess Julian Giffray raised the problem that Keith has never published his calculations. Keith has predicted on the basis of what I was saying, he predicted a new counterintuitive effect. He predicted that that the metamaterial, if it's highly diamagnetic, should have a big amplification of the coupling of electromagnetic fields to the gravity fields that they produce using the metamaterial as a transducer. Okay, and
Okay.
but the problem is that he has not shown how he derived that counterintuitive result. I mean, I hope it's true, because I hope it's true. That gives us, a big clue how to actually do the reverse engineering. Okay, so Keith Wanza has had direct input on my work, and so more recently has a Jose Rodal, who is a PhD aeronautical aerospace engineer with a degree from MIT, and now has he's older too. I don't think he's as old as me, but he's retired from a major German company, head of research and development or something, and he has his own consulting firm. And he works a lot at Princeton with people from Princeton faculty. So he's a very eminent guy, and he's done major work, and we're working together. And to some extent, Travis Taylor and I are in communication and beginning to collaborate. And of course, Travis, who he is.
Yeah, from Skinwalker Ranch. Yeah, Dr. Travis Taylor. But yeah. So again, I mean, these are just a few of the people that you communicate and collaborate with, even if it's not directly on this. I mean, if I started listing names, I would have probably the top people in physics.
That was like standard mainstream, theoretical physics, the Teller effect. I mean, all kinds of super solids. I was one of the first guys to, back in the 60s, produce super solids. Ray Chow and I briefly communicated back in the 60s when I was an assistant professor at San Diego State.
You guys are talking right now, actually. I've seen emails going.
But back then we were talking about, I published a theoretical paper on self-trapped laser filaments as being analogous to type 2 superconducting vortex filaments, showing the analogies between lasers and superconductors. And Ray, at that time, we were both young. I was in my 20s, and he is too. And he was a young professor at Berkeley. And he wrote to me saying that he read my paper and he was beginning to do experiments in self-trapped laser. And he said that my paper, helped him, was a positive for him. And now we're back together to some extent. And I'm trying to raise some money actually to give to Ray to check out his ideas in how spin, how entangled particle spins might amplify the coupling and allow a very practical transduction of electromagnetic waves to gravity waves, and back and forth, vice versa. And of course, that'd be a big thing.
Well, And so on that note, and on the on the note of raising money as well, I want to get into Lawrence Livermore. This is one of the things we were talking about earlier. So you sent me an email. Let me start with an email, quote unquote. I wanted to take a moment to acknowledge the significant impact of your theory. The fact that Lawrence Livermore Labs has utilized it for both a research paper and a patent on fusion is truly commendable. This application, which diverges from your original intention, stands as one of the highest forms of recognition a scientist can receive. While prestigious awards are certainly an honor, they often come after an individual has gained widespread fame and are based on subjective criteria. In contrast, this endorsement from researchers at Lawrence Livermore, a globally recognized institution, speaks volumes about the practical utility and significance of your theories. Your work, Jack, therefore can eventually place you in the esteemed company of luminaries like Maxwell, whose theories laid the foundation for the groundbreaking inventions of Edison and Tesla. These contributions have shaped our modern society, which is deeply rooted in the principles of electromagnetism. Congratulations on this achievement. Your dedication and brilliance continue to inspire us all. So let me, if it's okay, I'm also going to give a little bit of background here. So this was a project created by Dr. Michael G. Anderson, the lead pulsed power scientist at Lawrence Livermore National Labs. I believe it's called the Warp Reactor core, Warp Reactor concept, and it promises orders of magnitude more power based on intense ion beam energies and respective radiation yields at a fraction of the size and cost over existing Z-pinch class accelerators. He actually did a presentation at the APEC conference that I moderate a while back.
That's
and
how
he described this. And yeah, at the heart of this, I believe, is what he was calling the S field, right? And this is your work. This is your theory right there.
Yes, that's it. That's it. And let me just say, the particular version that Michael Anderson is using is not the Keith Wanza version. There's no diamagnetic effect. He's using about my original version from 2011 that I gave essentially at the DARPA NASA Orlando meeting in October of 2011, that General Pete Worden, who was then head of NASA Ames, had invited me, paid my expenses to go give this talk down there. So it uses my original version, not the modification that Keith Wanza has suggested, which would also be a different experiment, but maybe even more important because it would not require the tremendous machine energy that Livermore. All right, and I think it's the warp fusion reactor. I think he has the word fusion in there, right? Doesn't he?
It very well could be. I actually have. I have a copy of it. No, it's called the Warp Reactor Concept. I have a copy of his paper here. Do you want me to put that up? Why don't I do that real quick?
No, wait. But let me just say a few more words, then we can move on to other things. The particular test that he has, let's see, do we have a picture of the equations? That's it. Okay, that's the basic equation. So the S term is that's what I did in 2011 basically. And this other thing, the A term, is a rotational term. That's an additional thing that Michael G. Anderson has done, specifically to his machine, because it has these rotating beams and stuff, which I didn't have. So, but it's it's a similar term. All right. So now go down. Try to find table 9. Try to find table 9. Okay, table 9.
Table 9, metric engineering.
Yeah, that's it. That's it. Right there. The Sarfatti scale of factor. There, make it a little bigger. Sarfatti scale. Yeah, there. S. There. S. See that number? That's roughly 10 to the 32. It's a pure number, by the way. It's a ratio of two. It's a ratio of what that is. That's in this experiment. There's something called the relative dielectric permittivity, which is the dielectric permittivity of this plasma that he's making divided by the electric permittivity of the vacuum itself. And so that's a pure number. And that's, that's basically 10 to the 32.
Yeah.
So, all right. So what
Okay.
that
So,
means, what that
I'm
means,
sorry.
what that means is that the strength of the coupling of the electromagnetic fields in that plasma, in that warp bubble that he's going to make, those electromagnetic fields, their effect in generating gravity is 32 powers of 10 stronger than in the original Einstein equation. Okay. And what that means in this particular case, with his numbers, that means that what he proposes to do, this hasn't been done. This is a proposal, right? I want to make clear, this is a proposal. It's not a done experiment. What they want to do is to see if they can make this warp bubble that, using my theory, the warp bubble for the parameters of their machine will be about 1/10 millionth of a cubic meter in volume, and it'll generate a gravitational field at the surface of the bubble, this tiny little bubble, of 16,000 times the Earth's gravity. In other words, if you would weigh 16,000 times your Earth weight, okay? So that'd be very important to know if this thing works or not. All right.
Yeah, and unfortunately, I'm not seeing a lot of detailed graphics, although I do want to show people. So this is the ISO view of the warp reactor. I will zoom on it.
Yeah.
Yep. And then I will also show them. You had some graphics as well, and so these are those side view and.
Yeah. Okay.
Okay.
So I think we've said enough about that. We can move on.
Yeah. So again, the warp reactor is, and that isn't even directly related to UAP. That is energy generation, right? But again, this is the power of this model. Yeah. This is the power of this physics.
Yes. As the PhD scientist whose name I'm not going to mention, who you cited, because he hasn't really given me permission to mention his name. But it's important what he said is known,
and I will put links into the warp reactor core for people to review. Now, I want to get into UAP because again, I think anyone who knows anything about your work knows about the weightless warp drive, right? This is a form of warp drive. This is what UAP use for their propulsion, controls gravity with very low power, and you are proposing the use of metamaterials to make that happen.
Yeah,
right?
And I basically proposed that, back in October, I think 28th or so, in Orlando, Florida, at the Defense Advanced Research Projects Agency, NASA joint meeting of this so-called 100-year Starship project. And Eric Davis was there with John Kramer and Larry Lemke, and I think the Russians were there too. This is when Obama was the president, and things were okay with Russia. So the Russians were represented as well.
And so the key, if I understand this correctly, the key to the metamaterials is basically changing the gravitational refractivity.
No, that's actually that's wrong. See, now what you've done there, this is important. What you've done there is to confuse Hal Puthoff and Eric Davis's theory with my theory.
Oh, okay.
Their theory, they talk about like the refractive index of space-time, and even that kid, one of the guys, got confused on this because they sound to a non-physicist, it sort of sounds like the same thing. Also, Hal Puthoff has mistakenly, he thinks it's the same. He doesn't even understand the difference. Okay, no, this is the purely standard electromagnetic susceptibility, the electromagnetic dielectric response, and also the magnetic permeability response of real electric charges in the metamaterial to the applied electromagnetic fields. Okay, the applied externally applied electromagnetic fields from some kind of power, like a battery in the Tesla car. Okay, and by the way, those are not radiation fields. Those are what are called near fields. Those are like the inductive, the same thing. Most of your computer, all the fields in the computer are basically near fields. In fact, you don't want that. In fact, the far field, like the microwave radiation, that's bad. That's when people, the iPhone, right? Put the iPhone, and if those the far fields coming out of there may fry the brain, may be causing brain cancer, right? This is a real problem. People worry about 5G. Those are far fields. Far fields are dangerous. Far fields are used for weapons, directed energy weapons, laser beams. So near fields are not as dangerous because they're confined. They don't propagate.
And so the near field is confined to the material.
Yes,
and that's what allows the low power warp drive.
Yes. And the point is, now you also can have far fields propagating through the material, of course, and that's what the index of refraction. See, the index of refraction, and this has confused physicists, even Nick Herbert and other people, and even Nobel Prize Brian Josephson, they get confused on this. They don't understand what I'm trying to really say. So they get hung up on this. When you have a far field, say light wave or microwave, whatever it is, electromagnetic wave moving through a material, that's the index of refraction is the speed of the electromagnetic wave in the material is the vacuum speed of light divided by this index of refraction. Okay. And physically, it's easy to understand. Physically, what happens is that you have electric charges. So you have a photon, say you have electrons and photons. The electrons, say, in the material. The photon comes in, it gets absorbed by the electron, but then it gets quickly re-emitted after a little time till it gets re-emitted. So that time lag between absorption and subsequent re-emission, that slows down the speed of light. Okay, so that's why the speed. But, and now this is very important, the same thing happens in vacuum, as I was explaining before. In vacuum, the reason the speed of light in vacuum is 186,000 miles a second is because the photons in the vacuum, propagating through vacuum, they see a electrically neutral electron-positron, what are called virtual electron-positron plasma. And the same thing that happens there. It's called vacuum polarization. In fact, I did send a diagram. It's the Feynman vacuum polarization diagram. If you can find that, I thought, well, in any case. So the point is, it's the same mechanism. Electric charges scattering photons are what determines the speed of light, whether it's vacuum or material. It's basically the same scattering mechanism. All right. And this is extremely important because what Einstein did in 1915, he has a coupling. It's Newton's. See, it'd be nice to have show the equations now.
Okay, and these are the slides that you have sent me.
Right, that's 37. That's it.
Okay.
There. Okay, this was a slide that David Chester did some years ago, and what we're looking at is the coefficient. See, 8 pi g over c to the 4. You see that? Okay, 8 pi g over c to the 4. Okay, and now this is Einstein's field equation, basically. The left-hand side, the R's, that's the gravitational warp field. That's the UAP warp field on the left-hand side. Okay, you see, and then there's the S field. The S field, it happens to be a complex field, the capital S with the little vertical bars. That's called the modulus, the magnitude. And then it has a phase. There's a phase factor. That's the sine of phi. And actually, that phase factor, well, I won't go into all the details. And here, this is the TAB, the T on the right-hand side. That's what's called the stress energy tensor of the applied electromagnetic field inside the metamaterial. So what that actually is, what happens when photons are inside matter, they interact with the electric charges and they form what are called composite things like things called quasi-particles called polaritons. And this is condensed, this is quantum field theory of condensed matter physics. But the point is that it's this this S field here, you see, that is what amplifies, that's what makes the warp drive possible with low power. Because what you want is on the left side of the equation, the R, the capital R's, you keep that fixed. That's the desired warp field. Suppose you have a tic-tac. Okay, yeah, you have a tic-tac and you have Commander Fravor and his F-18 is doing a dogfight with the tic-tac. That means that the pilot inside the tic-tac, he's changing the capital R functions in time and space in such a way as to, it's this R factor, what I call the curvature, that controls the path of the tic-tac. So he has to change it very quickly in time. He's, they're doing a dogfight, they're maneuvering. So this R is changing very quickly in time. And that means that he has to change both the S field and the theta. He has to change that very quickly in time as well. And but now the point is that this is being done in the near field. This is being done not for waves. It's being done for the near field. The warp field is a near field. You can also do it for the far field, but when you do it for the far field, that becomes a directed energy weapon. Now, I don't know if this may be too complicated for people. I don't know if this is going to work. What do you think, Tim?
Oops.
Yeah.
Okay. Yeah.
You see, most people, we may lose them.
Why don't we'll move on from this. No, I think that we've done okay covering this so far, but
okay.
Yeah.
Well, when you look at the video, you'll see.
So do you want me to go through? Do you want me to go through the slides to start with, or
that because
okay.
that will
Okay.
structure the thing. It's hard to describe this stuff because it really is advanced physics and it's mathematics.
Yeah, well, and again, I'm going to ask the audience to bear with us. We're jumping around a lot, but that's because you have so much history and legacy and material, and it's all over the place.
Well, and you'll
Richard Dolan, intelligent disclosure. He's saying he once brushed off time travel like dust from old books, but now it's hard to ignore. From space-time metric engineering to the musings of scientists, this speculative physics is opening doors. He's not sure if this is like H.G. Wells, but maybe we're on the brink of bending time. So one of the things that you've said is if you master warp drive, you master time travel, right?
Yes. This is a big thing, time travel. Now, most people, this is like too much for most people.
Yeah.
Time travel, that it's real. And it's certainly going to be too much for most, I think it's probably too much for Christopher Mellon and Luya and these guys. I think this too, they're going to balk at this. I think. Maybe I'm wrong. They're going to say Jack is crazy to say that. But I'm not the only one who says it. There's, did you have Michael Masters on?
Yeah, and Michael Masters has proposed that, and it's one of those, it's interesting. I'm starting in terms of UAP, time travel is being started to. People are saying time travel in whispers in different areas, and it's starting to gain volume. We'll put it like that.
But but the point is, I'm shouting it from the rafters. They're whispering. Sarfatti's shouting it because Sarfatti is the only real physicist in the game. I'm sorry. In this game, I'm the only one with a PhD from a top university and who studied with people like Hans Bethe.
Okay, let me take things down to light cones. Can we get a light cones?
Yes, do the light cones. All right.
Okay, and maybe you could walk us through this. We've gone over this in past podcasts.
Yeah.
This is probably the one to start with. So the light cone, basically, this is where an observer is. They're traveling. We're all time travelers all of the time, right?
Yeah,
we're traveling through time.
Yes.
So we have a past light cone, which is down at the bottom. That's where we've been. We have a future light cone, which
Right.
is where we're going.
Okay, and the detector, but move your thing down. The detector's right at the at the intersection, right at the corner, at the origin there, the light cones. You see,
Yeah.
right there, the observer. You see the observer. That's the observer. You see that? That's
And
important.
that's just based on the speed of light and how light diverges, and that's where we can go in terms of
Okay,
time.
okay, but
right?
let me say a little more. But this is the basic structure in Einstein's theory of special relativity. This is it. This is the basic structure. Okay, and the observer. Think of the observer as a small particle detector. It's really a particle detector. Okay, and the past light cone are signals coming into the detector that'll cause a click on the detector. Okay, and the future light cone are like if the detector is also a transmitter. I should call it a detector transmitter. What do you call them? Transceiver.
Transceiver.
Transducer is a little bit different. Transceiver. It's transceiver. It both can transmit and receive. So it receives in the past light cone, and it transmits on the future light cone. All right. And all the light rays have to lie. This is classically now. Quantum mechanically, it gets fuzzy, but this classically. So these are for what's called geometrical optics limit, where the wavelength of light is small compared to the apertures. So this is the deal. Now, all ordinary matter has to move on what are called world lines that are inside the light cone, inside both the past and future light cone. That's all ordinary matter. Okay? Slower than light. Everything inside the light cone is subluminal, slower than light. Right. And everything outside the light cone, that would be faster than light. Tachyons, which most people do not want to accept that. And actually, I don't need that. See, what I'm talking, when I talk faster than light now, it's still inside the light cone, because it's the light cone itself which is going to
Okay,
tip.
well, so if it's okay, let me go to our next slide where we're showing, and this one, you've gone through this before. Let me apologize for being fuzzy. I don't have my notes on it. But this is a way to express time-space where you have many, many light cones.
Yes,
and then you're going to show them.
Every point, and by the way, this is from the Stanford Encyclopedia of Philosophy, I think, that's online, and this is, everybody should look at that. Yeah, it's Plato, Stanford. It's called Space-Time Singularities Light Cone. And so this is special relativity where there's no gravity at all.
Okay.
It's called flat space-time. Time is the vertical axis and space is the horizontal axis. And you see here, all the light cones are parallel to each other. You think of it, think of analogy that they're like analogous to spins in a ferromagnet. All the spins are lined up parallel to each other, like in a ferromagnet.
Yeah.
Okay. But that's
and
that,
so that would be that would be analogous to this as well, right? Where you have
this is an example of that. This is where Bob is sending a signal to Alice. So the red triangle, the red upside down triangles, that's the future light cone. The blue triangles are the past light cone. And what you have here is Bob has to send a signal to Alice at the speed of light. Oh, by the way, this only works in vacuum. All of relativity, when Einstein did relativity, he was not doing light moving inside matter. See, this is a big restriction that people don't understand. What Einstein did was to use what are called thought experiments, Gedanken experiments, and he was visualizing, Alice, he didn't call them Alice and Bob, but he was visualizing clocks moving, meter sticks moving, and how do you make the measurements? Everything is very operational. He was at the patent office then, like he was thinking like an engineer almost, he was thinking like an experimentalist. Okay. So this only works in vacuum. And there's no dispersion. In other words, the speed of light does not depend on the frequency of light. Microwaves, optical waves, X-rays, infrared heat rays, they all will move at the same speed, 300,000 meters. I'm sorry, 300 million meters per second. The same as 186,000 miles per second. Okay, they'll all move at that speed. If they all move at different speeds, we're in trouble, because the light cone, that fixed light cone, will then spread out like, the fixed. If the speed of light depends on its frequency, then you don't have a unique light cone like that. It's like a spectrum. It's like Newton's prism. Newton's prism breaks up the light into different colors, moving in different angles, right? So the same thing would happen with the light cone. Then you're in trouble. This is a big restriction on the theory of relativity. We just happen to be lucky that our vacuum is not dispersive in the range of frequencies that that we use. If it was, we'd be in trouble. Okay.
Okay. So let me scroll down to this one then.
Yeah. Okay. So this is now, when people talk about faster light, they think it's this. This is not the right picture. This is wrong. This is what people think, but it's wrong.
Okay.
Okay. In fact, even guys like Hal Puthoff and even I, to some back in the 60s and 70s, this is kind of, we were thinking like this, and that's wrong. Okay. Let's go to the next one.
Okay. And so this is more accurate. And you've talked about this before. The light cones are tipped. That's the important point.
Yeah. And it's the tipping, that is the curvature. That is gravity. Gravity is the tipping of the light cones.
Okay. And I can scroll. Let me scroll down again. So again, back to Alice and Bob with tipped light cones.
Yeah. Now this is the extreme case. This is where where Alice's light cone is perpendicular. There's so much curvature. The two light cones are perpendicular. Okay. What does that mean? That means, from Bob's point of view, Alice looks like she's going at an infinite velocity. And it's reciprocal. From Alice's point of view, it looks like Bob's going at an infinite velocity. Okay. But inside, each one of them are moving at in fact, inside, you can even say they're not even moving at all. They're just like, they're actually on what's called a weightless geodesic. Okay.
Okay.
So locally, they're not doing anything. Everything seems normal to them. But now, if say Bob is on Mars, and Alice is on a tic tac that's going from Earth to Mars. Okay, so Alice can see ahead, because what Alice is doing, Bob is sending out what he thinks is a retarded far field light signal, which then enters Alice's future light cone. So to Alice, Alice thinks she's getting a signal back from the future because it's in her future light cone. Okay. But she can actually see what's ahead of her. She can see Bob. So so this is important to realize. Okay, so Alice can actually still navigate, and she can see what's coming because of this kind of situation.
Okay, and then going down to the next one.
This is just a bigger view of what I was trying to show. Okay.
So,
but you're also starting to get into time travel, which is how we came here.
The next slide. Go to the next slide. This is time travel to the past. This is what we were talking about the other day. So the point is this. Let's call this Alice. Say this is Alice's ship, right? She is able to control the tilting or the curvature field in her metamaterial fuselage. She's able to control it with a Tesla battery, small amounts of energy. All right. And so she can do whatever she wants. See, she's able to control the tilting of her light cone relative to the stuff outside. Okay. She's able to control it with small amounts of energy. And what I'm claiming, this is what we actually see. This is how to understand the six observables. Where are the six? Go back to the six observables. Where was that now? The six observables.
There we go.
Yeah.
Yeah, and you've added one just for the audience. You've added biological effects.
Yeah, actually, Julian Giffray did that. And that's the stuff that Gary Nolan and Kit Green, that's what Gary Nolan's working on. Or one of the things. He's also working on retrieved materials. And by the way, I fully support Gary Nolan's scientific research in both retrieved materials and in the blood, the blood work, the damage from the anti-gravity blue shift from the sources. I support that. I don't support his non-scientific political program from the Soul Foundation that he just gave at Stanford, with all this disclosure nonsense.
Well, so we should get the biological effects are, and I don't think you've gotten into that, but when you're bending gravity, you're creating a red shift and a blue shift, and
yes,
you will blue shift, basically you'll blue shift air molecules underneath, right? And that creates ionizing radiation.
Yes. That's, we was talking about when Travis Taylor and the guys at Skinwalker Ranch got sick. They claim that there is some kind of an object that's cloaked, that's hovering. It's, in other words, in order for it to stand still in the Earth's gravitational field, it has to have a blue shift underneath. It's generating a blue shift, an anti-gravitational blue shift underneath it, which means that any air molecules, they can get ionized. They get ionized and cause dangerous ionizing radiation. So they got a mild form, hopefully a mild form. It didn't kill them, of radiation sickness, and that's exactly what is in the blood samples, I think, that CIA's Kit Green has given to Gary Nolan to analyze with his instrumentation. These are about 100, roughly 100 military people and CIA people who either got sick, and apparently some of them died from it, from getting too close in the wrong way to these craft. It may have just been accidental because they didn't understand what they were doing.
So one of the things that comes out of your research is this idea that UAP must be modifying gravity for propulsion. It is not conventional propulsion. Yeah. Otherwise, there's absolutely no way to explain the kind of performance that's been described, right?
Yeah, and with my equations, it's easy to understand it. In other words, I'm saying that all the observations that are reported by Commander Fravor and Ryan Graves, all these Navy pilots, is smoking gun evidence for control of gravity with small amounts of energy, not using a lot of energy, obviously. Because if you look at the papers of Avi Loeb and Kirkpatrick and Kevin Knuth, where they're assuming it's conventional propulsion, they come to the wrong conclusion. They're saying, well, it can't be material because there'll be too much energy, there'll be too much heat generated, too much stuff in the atmosphere. They don't see that. So it's got to be, I don't know what they think it is. they say, and then a miracle happens because they don't seem to understand what warp drive is.
And if I could jump in, I'm going off memory, but one of the things that Dr. Loeb and Dr. Kirkpatrick had talked about was confusion and concern about fireballs from objects traveling that fast in the atmosphere. Yeah. And then there are other concerns about, again, any kind of human-built airframe would be destroyed by the kind of acceleration.
Yeah.
50
and the point
Gs
in warp drive, the actual G-force inside the warp bubble is zero, even though it looks like it's 5,000 G to the outside observer. So all that is so explained. It's so elementary. That's why it gets me frustrated and angry. I'm sorry, but I can only call it the stupidity of my peers, my so-called peers. The lack of knowledge of elementary physics, as I was taught by Hans Bethe and Richard Feynman and David Bohm and John Wheeler. I was even spent weeks with Werner Heisenberg in Munich at the Max Planck Institute. Okay, so this is where I learned my physics. I know where they learned their physics, right?
Okay, you have talked about what's called a white hole force field.
Yeah.
which would be required. Now, you could use that for defensive purposes. I've
Yeah.
also thought that that would almost be required to repel like space dust, right? And
Yeah.
atmospheric molecules and water when it goes in the ocean
Yeah.
with
Yeah.
transmutation.
As a matter of fact, they've already these okay, when with some of the retrieved craft, when they first got there, they got some intact, like David Grush says, there's intact craft. And then when they had it in the hangar and they're trying to, explore it, and they take acetylene torches to it, and they can't even dent, they can't put a scratch on it, they can't do anything. It resists heat, whatever they can do, it resists it. Okay. Why is that? Because, okay, first we got to understand these things. Oh, yeah, that's the other big thing. Besides time travel, see, besides time, I mean, I'm blowing these people's minds. They just, they go crazy. Well, these things are alive. They're conscious artificial intelligence. They have our kind of consciousness. Okay. So they have a will of their own. Okay. And if they sense that some schmuck has taken a acetylene torch to them, it's like a skin. It's like you're putting a torch in my skin. Fuck you. It'll activate the anti-gravity force shield, so it doesn't do anything. It can then switch it off. And if it likes you, it'll let you inside the interior. You understand? You're not dealing with a dead piece of metal. You're dealing with a non-human, okay, it's a non-human conscious artificial intelligence. So what do you call it? NHC AI.
I'm on vacation from acronyms this week, so I don't know.
Yeah. So the point is, this is interesting because when George Koopman and these other guys from the CIA and the Army, the Air Force, when in the 70s they said, Jack, CIA wants to know two important things. How does consciousness work? And how do flying saucers fly? The two things are two sides of the same coin. And it turns out even the physics, there's even a connection to physics, which has to do with Lenny Suskind's, ER equals EPR, all that stuff. And so there we have it. So it's actually a pretty story. It's a very, the narrative. See, right now we have a conflict of narratives. You have guys like Louis Elizondo, Chris Mellon, Alexander, and, Jacques Vallée, Gary Nolan even is on their side now, and they're trying to pitch a certain narrative to the public and to the politicians, Tim Burchett, all these congressmen, Chuck Schumer, all these guys. They're trying to pitch a certain storyline, and I'm claiming that story is no good. Don't listen to their narrative, because there's serious things wrong with it, and the Russians know that. So what's happened now? I don't know. If one parents say, well, listen, disinformation. You talk about fake news and all that stuff. If you believe the wrong narrative, and then you give the Russians a head start, if they have the real narrative, they have the right stuff in Russia, because they listened to Jack Sarfatti. They invited Jack Sarfatti to Moscow, in July.
My thought had been that there are.
Saying here?
Yeah, my thought had been that there are multiple confusing. I would agree with you that they all had the same narrative, again, up until David Grush appeared. And now it seems much more convoluted. And I get the impression, so I'm not disagreeing with you, but it seems like it really seems like he threw a monkey wrench into things. It seemed like it was a very consistent story moving forward. You started with Nimitz and you moved.
David Grush was simply saying basically what I've been saying for years. I mean, there's not that much different, right? Some of his physics isn't right, but that's it's a minor thing.
Again, just as a layperson, what I see is there was old school and new school UFOs, and what David Grush really did was unite those two, and he did it in Congress, right? Where he took 75 years of UFOlogy and connected it with UAP, and he said, look, these are the same.
Yeah. Oh, yeah. Okay. Yes, that's true. But the point is, none of them, including David Grush, they do not have a clear understanding of the simple physics that explains it.
Well, Jack, let me thank you so much for your
Yeah.
time today. And let me close by asking, what is coming next in the next few months for your work, and what do you see coming up for the UAP story in general?
Well, I hesitate to even say anything about that because there are things happening, but I have to sort of keep them. Basically, okay, what I can say is this: we don't need disclosure from the government. We don't need the government at all. Let's leave it at that.
Thank you again so much for your time today, sir.